Today we're going to be looking at this juntek amplifier. It's a 25 volt peak to peak amplifier that's intended to be used with a tone generator. This is why it only has a 6 dB output, and that's because you can use this in conjunction with it, and most tone generators have at least a 20 volt output. The reason you'd want to use this is so you can get the current, because most tone generators you don't want to output very much current to. I know the Siglant model I have next to me, the SDG 1032X, can only deliver 200 milliamps, but you wouldn't want to do that. So you get one of these to be able to do that. I got this because I wanted to do medium frequency bandwidth testing. That's the frequency I'm really interested in, because the human body has frequencies that resonates with it. But that's a story for a different day. So let's open this thing up. What I'm expecting to find in here is a couple large power transistors, a gate driver system, some power filtering, and I think some pretty major heat sinking. This thing has an input of 5 amps at 12 volts. That's pretty substantial. So I would expect to see that this thing has some pretty substantial power dissipation going through it. This does have a little fan on it, and this case is all metallic, but the casements on these usually don't get done with a lot of heat sinking, unless they do. It's kind of hit or miss on that one if they decide to put thermal pads on the top of it. If they do, it's going to be an absolute pain to slide this out, so let's see. Oh, the fan got gummed up. Come on, there we are. Okay, interesting. I was not expecting to see such a small heatsink on this. I was expecting to see like this giant ducted thing. Here's the little fan. Really nothing to write home about. So if we take a look at the back, we immediately see ourselves a little bodge right there. That's interesting. It looks like it's bridging between the two ground planes there, but I don't know why they would have those ground planes separated. And they really just scraped away at that and put a ball of solder on that. Let's get this heatsink off. Should be pretty easy to remove as long as they didn't put any heat sinking compound or epoxy on here. Interesting. There is no heat sinking compound on that. And we see that there is no names on these chips. They have been laser bladed off. You know, if you want to be sure, there's the serial number of it. Okay. Interestingly, these caps are the wrong size. They just kind of threw them in here willy-nilly. So the reason I say that is because these normally sit flush. And usually when they sit sideways, they've installed a bigger capacitor. And usually it's not bigger in quality. It's usually bigger because it's cheaper. So right here on our input, we have a capacitor, we have a resettable fuse, and we have this inductor for power conditioning. And we have this anonymous 5-pin chip. I'm guessing it's just going to be a boost converter. There's really nothing special about it in the location of it. Doesn't have a whole lot going on next to it either. Yeah. Interestingly, all 6 of these chips associated with the amplification have all of their numbers scrubbed off on it. Um, I'm actually curious about the grounding situation on here because of this one bodge wire. So let's bring in the meter. So I actually keep the batteries and my meters out. This is not the meter I use every day. I typically will use a cheapo meter because typically I'm not worried about if it has 5 volts or 5.1 volts on it. Or in my case, actually, if it has 120 volts or 121. At the end of the day, if it has power, it has power. But the reason I like this one is because it actually has a really, really good non-contact mode. So when you have a good non-contact mode, you can just touch things onto it and it will immediately tone. Whereas some other ones, if you just barely touch it, it won't do anything. So let's interestingly that's not. So just for common grounds. So here's the ground. Yep, that is the ground. So yep, that is common ground. Where do we want to test that? Let's just do across these. That's interesting. Where's the ground coming from? That's just weird. There is no ground pads on here. That's just weird. And here's our circuit ground. Here's the chassis ground. So you'd expect to see some sort of ground. That's just bizarre. I don't know what's going on there. And we have ground there. If we trace that back, traces on this circuit board are kind of hard to see. Yeah, that's weird. And they have all of these chips burned off. So trying to discern anything on this is going to be very difficult. In fact, besides looking up what this chip is, I'm not really sure. And this doesn't even really have an inductor associated with it because if we trace these back, these I don't really see a path for these. There is not. Trying to see, because over here might be the power supply section, but why would this chip be so far away from these two inductors? That's kind of where I'm at, because normally you'll see these inductors be right next to them. Honestly, besides just like poking at this power pin and seeing where the output of this chip goes, I don't really know. And to be honest, there's not a whole lot I'm going to be able to discern from this. So I think we're just going to have to leave this for the next episode where we start to characterize these. What we'll do is we'll plug this into an oscilloscope with a function generator and we'll do a sweep test over the whole range of its output with various different loads attached to it. And that will show us the characteristics of it, and we'll try to characterize a whole bunch of these. That's going to be an upcoming series we're going to have, so If you're looking forward to that, please like and subscribe, and thanks for watching. Have a good day, and I hope you enjoyed the content.